Module 2, Lesson 1 is distributions and their shapes. Our outcomes for this lesson will be to describe the shape, center, and variability of a distribution on a dot plot, a histogram, or a box plot. And then 2, determine the meaningful conjecture to connect data distribution within the context of the data. So if you're just joining us for this video series and you haven't been with us in Module 1, it is important to note that the purpose of this video is to provide a resource for both the parent and the student where both can review a lesson at home to improve classroom learning and to provide improved homework understanding. So in this particular lesson, it's more of an introduction or a review, well, I'm not going to say review, but a discussion on the differences and the similarities and answers we can come up with between a dot plot, which is what we see here, a histogram, and then a box plot. So we'll just take a look at this momentarily in example 1, where there's really no questions that are being asked here, but to just look at and define that a dot plot is a plot of each data value on a scale or a number line. So here we have a number line from 0 to 80 with dots placed on top of each one in various locations. And one of the things I guess that's interesting to note is that in some locations you have a large number of dots, where in some other places you have just one, or in some areas where you have none. And so it kind of gives you an opportunity or a frequency of how many times something happened for a given value. So if we were to count the dots over on this one, 1, 2, 3, 4, 5, 6, 7, 8, that this occurred 8 times within that particular study. We'll talk more about dot plots in a later example. So in example 1, S1 here, analyzed together, they bring up this idea of a histogram. And so this definition is just a graph of data that groups the data based on intervals and represents the data in each interval by a bar. And so the idea of a histogram is the purpose of, or the idea of working with intervals. So we might say right here, this bar right here at the top, this one right here, goes from 0 to 5. So anything that might occur 0 through 5, or 0 up to 5, and then here in between 5 and on up to 10, and then here from greater than 10 to 15, and so forth down the line. And so it's interesting to look at, identify that the frequency in which something occurs up here at this point, and to which it's curving down and becoming less frequent or less popular as we go down. Other things to note, this is a percent versus the age in years. The histogram is for ages in Kenya. Another piece that's being looked at the students will analyze is here is a box and whisker plot, or what may be known in this book as just a box plot. By definition, a box plot is a graph that provides a picture of the data ordered and divided into 4 equal intervals that each contain approximately 25% of the data. And so what we mean by that 25%, if I look at it, we've got part 1 here, part 2, part 3, and then part 4. So this would be where 25% of our data is. Here would be another 25% of our data. This would be another 25%, and this will be another 25%. So one thing that's interesting to note, if I was to look just at this part right here that's in the box, together that would be defined as 50% of our data. And so again, we'll look more in depth at these as we go through the presentation. So in exercise number 3, the teacher is going to be having a class discussion, just trying to get the students to talk about what they see, what they observe, and what they think is going on. And so here we apply a scenario to this dot plot. It says transportation officials collect data on flight delays based on the number of minutes past the scheduled departure time that the flight takes off. So they want us to consider this dot plot of the delay times for 60 big air flights during December 2012. And so here we are, if we just look at the dot plot, we've got from 0 minutes to 120 minutes late. This is a dot plot for December delays, And so some of the questions that might be brought up is like this one right here. What do you think this graph is telling us about flight delays of these 60 flights? And so through discussion, students may say this idea or that idea. But one of the things that would be popular to note is right here, we have many of our dots right here. So most students might say that most flights are delayed for about 15 minutes. And so, and then some students might say, well, yeah, well, there's a whole bunch more that are delayed for a lot longer time. And so we're just having that discussion about, yeah, 15 minutes was a very popular time, followed by 20. But then you start to see this grouping around here, anywhere between roughly, let's just say about 15 to about 35 minutes seems to be our most popular delay times. And so those are just some of the descriptors we're trying to get some of the students to talk about, discuss, and think about. So another question that may come up is, can you think of a reason why the data represented by this graph provides important information, and who might be interested in this particular data distribution? So one of the things that might say why this is important, if flights are late by this particular airline all the time or consistently, then they might not select this airline. So it's about consumer reports and data being driven by the company to decide where their biggest issues are concerned, where customers dissatisfied with, and where they could improve. And so that would be why this would be interested, or who would be interested in that particular data. And then finally for this one, based on your previous work with dot plots, would you describe this dot as representing a symmetric or a skewed data distribution? And so we would hope that the students would come up with the idea of the fact that this data is skewed to where the bulk of the data is here. And what we see is kind of, if I was to draw an illustration, to where we start up here and it kind of gets less and less as we go towards this side. And so we would describe this data as skewed, and we would describe that with a tail to the right. As we can see, as we're going towards the right, it has started to become less and less, or where we define where that tail would be located. In this dot plot, in exercise 4, it gives us a random sample of 80 viewers of a television show that was selected. The dot plot below shows the data distribution of the ages in years of these 80 viewers. So we have 80 dots throughout the piece. And looking at where the distribution occurs and so forth in this design. So what do you think this graph is telling us about the ages of the 80 viewers in this particular sample? And so we might look at it and think about a television show that was selected. We might say that the typical age of viewers, and that's what's missing on the bottom of this, we want to note that this is the age, or the viewer age. So we know what kind of data we're talking about, and that would be in years. So looking at this, we might say that the most popular viewing age seems to be somewhere between this area where is the bulk of our data. So we might say typically our viewers are in between the ages of 60 and 75-ish. We'll just call it all the way up through 80. It's where the bulk of our data is sitting at. Can you think of a reason why the data represented by this graph provides important information, and who might be interested in this type of information? So this data is important in understanding that the audience of the show. This could come into an importance for commercials. So if you're an advertiser for this show and you know that your demographic that's watching this particular show is between 60 to 80, then I might try and court advertisers that want to advertise to that group, and so forth. So in a design, I would not want to air a commercial for a toy age someone that might be around the age of 10. I would be interested in something that might be a little bit older, a sporting commercial or some medical commercial or important new drug or something like that to help someone between the years of 60 and 80 years old. So based on your previous work with dot plots, would you describe this dot plot as a symmetric or a skewed? And so again, when we kind of look at it, we have a lot of our data over here. And so if we want to describe it, we would tend to have a lot of data over here, and it tends to skew as we go across over here. So we would define this as skewed with a tail to the left. In the next example, we'll go back and look at that Kenya histogram. So the following histogram represents the age distribution of the population of Kenya in 2010. And so, again, same discussion is being continued on with the class from the teacher, but just more things this time geared towards what a histogram might look like. So in this one, what do you think this graph is telling us about the population of Kenya? And so we see right here 18% or 17% of our population seems to be in that 0 to 5 range, or if I took right here, my 5 to 10 range would be around the 15% mark. So what we want to look at is the bulk of our data. What students will probably say is that a large percentage of the people in Kenya are ages 10 right here or younger. So a lot of people are very, very young in Kenya based on this particular histogram. Then the teacher follows up with, why might we want to study the data represented by this graph? Well, and there's a lot of different ideas that students could come up with, and the teacher will be open to a lot of these ideas, but just for one example, you might say it tells us about Kenya and its challenges based on its population and demographics. Caring for and educating young people are major challenges for this country. They have a lot of people that are young by comparison of people who might be, say, 80 or 90. So a lot of their challenges would be, are the schools proper for education? Is there proper daycare centers, health supplies for young students or young people in the country and so forth? And they want to work on having that work. They also might say is, why is the population so high young versus why is it so low? Is there a reason why people are maybe not living to a long age? Or these are questions that students might start to ask and can't be necessarily evident in this particular histogram, but can be brought up as questions of inquiry. And then finally, based on your previous work with histograms, would you describe the histogram as representing symmetrical or skewed data? And so again, this is another skewed data here, and it's very evident where most of the data is here, and it skews and tails off towards the right. So we would say skewed with a tail to the right. We'll look at this histogram here. For the following histogram represents the age distribution of the population of the United States in 2010. So we just looked at an age distribution for Kenya in 2010. By similarity or contrast, we'll look at the age for the U.S. And so what does this particular graph tell us about the population of the United States? And so what the students are kind of looking at and seeing is, like, for the most part, for a large populace, we seem to be pretty leveled out until we get somewhere around this 60, 65, and then we start to see it tail off. But one thing that's interesting to note, it goes all up to 105 here, where in Kenya the average age tends to have gone up to about 90s where we stopped that particular histogram. So what does this tell us about the population? Is that the percentage of the population is about the same age in each interval until around 60 or 65, and that's where we mentioned it starts to drop off right here, and then the percentage starts to decline. Why might we want to study this data represented in this graph? Well, it's important to note that the population data are used for determining health care challenges, just like we talked about in Kenya, though the healthcare challenges in the U.S. would be a little bit different, whereas we need to look at a much larger age demographic, where Kenya just focused on, 10 and under. And so, and also those same educational challenges go all the way up through 20 years old, whereas Kenya may just be focusing on early education practices. We want to be able to make sure our educational system is good for elementary, middle school, high school, on up through college, and then adult education beyond those potential reasons. So it's interesting to compare the two histograms and look at the same questions as to what may be important in one country versus another country. Here we have our box plot. So again, just to remind ourselves, in a box plot, each part is worth 25% of our data. And so here we give a scenario where 30 students from River City High School were asked how many pets do they own. And then the following box plot represents that data from the survey. So it tells us certain things. If we look at the question directly, it says, what does the box plot tell us about the number of pet owners owned by the 30 students? Well, one thing that we can point out or note very easily is that if I just look at that 50%, I could easily say that 50% of the owners own between 1 and 5 pets. That's one thing that's real easy to take a look at just as an example. Why might understanding this data behind the graph be important? So we might say that understanding the data is important for planning special events involving pets and understanding the interests of a certain group of people. So it might be important to know that our owners, or 50% of our owners, own between 1 and 5 pets, whereas likewise only 25% of our owners own greater than 5 pets. Here in our final example, we have one final box plot where it says 22 juniors from River City High School participated in a walkathon to raise money for the school band. The following box plot was constructed using the number of miles walked by each of the 22 juniors. And so if we play that same 50% idea, if we know that in between here and here, so between here and here is 50% of our people, so we might say that 50% of our walkers walk between 4 and 9 miles. Likewise, we could say 25% walked between 9 here and 11. But we could also say another 25% group walked between 0 and 4 miles. So we can kind of look at that demographic and data and see where each one is in that particular design. And so then why might understanding this data be important in the graph? Again, it would provide an indication of the participation level of the junior class. Sponsor of the event may be interested in this particular data and what's going to happen. So as a lesson summary, what the students are going to be focusing in Module 2 is everything about statistics. And so the students need to be able to define and understand that statistics is about data. Graphs provide a representation of that data distribution. And in this particular lesson, we looked at 3 different types. We looked at a box plot, we looked at a histogram, and we looked at a dot plot. And then we noticed some of these were skewed. And so this is used to understand the data and answer potential questions about the data. Companies and businesses and science research are interested in this distribution and how the data plays out and could affect certain things in this particular lesson. So thank you for listening. Come back for Module 2, Lesson 2, and learn more about statistics and data distribution.